Welcome to Trees with Squill, a podcast hosted by Squillum. In this podcast, we will discuss trees, forest science, lignin and the like. Now let's branch out and leaf it all on the table.
Hello, welcome to a very special episode of Trees with Squill. It's very special because it's the second episode, which all 700,000 of you have been messaging me to do already. And I've really kept you guys hanging for this, but that's just a product of me living a busy life as a tree person. The other reason why this is a very special episode is, as you can tell, I'm making a video. I figured it might be easier if I want to edit stuff, but I'm also in a forest, so I thought it would be suitable to record an episode of Trees with Squill whilst trees are in the background. Maybe I should just stay out of the frame. That's quite an attractive backdrop. And it's really annoying with the light. It took me a while to figure out how to make it good. Anyway, I've got my cup of juice. Wow, I hope you do too. So, I did say last time that I would talk about wood science in the second episode, and I really should, just so that things make sense. But the thing is, wood science is actually such a big topic, and I want to get it really down pat and good, because it can get very confusing very easily, unfortunately. I am very wet and soggy because I went for a walk and it's pouring rain, and it got even more pouring rain, and my silly little waterproof jacket is not waterproof, despite getting very soggy though. I mean, I got starving and stuff by the end because it was lunchtime. But on the way out, I was warming up for this podcast, talking to the trees. Because I tell you what, rainforests are bloody interesting, and they have a lot of tree forms going on. And I don't know a single Okay. I know dogwood, and I'm pretty sure I saw dogwood, but other than that, I can tell you the single name of a single species in there, and that is so exciting. There's so much to learn. And there's one that I've been talking about recently with everyone that is mildly interested with vegetation. There's one species that, let me get out a picture and show the video form, but I'll also post it on my Instagram once I identify it. Because there's an arboretum in Gnelaba that I visited, and this species grew there, and what it does is it has like green leaves obviously, but the young ones supposedly, or presumably I mean, on the end of the shoots are pink, and that is incredibly fascinating, because why would you want young leaves that are pink? So I asked a friend recently, and she reckons that it's a nutrient supply exchange thing, and perhaps they're just pink because rainforests can do whatever they want. The young ones are pink and they droop, and then the older fellas are like mad chillin'. And there's a mature version right behind the young sapling with the pink shoots. It's really interesting, the old nutrient supply. It's theoretically much like how trees lose their leaves in the autumn to save nutrients. It could be that these leaves are pink because they don't see the need, if you will, to supply nutrients to such young'uns. And I mean, the mature one, as we could see, was quite large, so I guess it makes sense that it would want to savour and distribute nutrients in some way, some orderly way. But anyway, today I've been think about some things. I want to talk about just briefly my opinion on fire breaks in forests, and then the main show will be bark beetles. And look, I made it really easy for myself because I could talk about these, I suppose, a lot. I've been thinking about fire breaks a lot because for those who don't know, I'm a runner, and so I've been looking on this website called All Trails to find places to run and good courses and whatnot. You know, and you can download the map so you don't get lost. Well, I've paid to be able to download the map, so if anyone out there wants me to download a map for them, I'm happy to do that. Give you the GPX file because it's good for safety. Have it on your watch and your phone. But anyway, I noticed that a lot of the reviews from hikers on these courses were very boring. Forest fire break trail, so boring, or something to that degree. And I just find that so interesting because from like a sustainability point of view, a forest almost can't exist these days without some kind of fire trail break, you know. The fire trails provide a clear disturbance to the forest dynamics, which slows down the rate of spread of any wildfire. It's kind of like a second little backup to a firefighting crew, or a first response, really. You don't need anyone there for the fire break to do its thing, and that's why they're good. So I get why they're boring, but then also I feel bad like running through a forest if, you know, if the trail's not well defined, because then you kind of feel like you're doing some damage and you could be collecting seeds or diseases unknowingly on the bottom of your shoes and spreading them to the next bit. So fire breaks, given that they are almost certainly going to always be there, it's kind of just a safe passage to look at stuff through without guilt, perhaps? Ecological guilt? Can I coin that term? I don't know. Something like that. But yeah, I also do get why they are boring, because like one I ran through, it was like a 15k out, 15k back. So 30k out and back trek. The fire trail was so well made, and like it actually had gravel on it. So it made it so easy to run on that I kind of forgot that I was running, which was cool in a sense, but I guess if you're walking, perhaps you don't zone out as much. Maybe you do. I know I saw a dingo that time, actually. I'm happy to announce to all of you listening at home. The dingo was pretty cool. I was a bit confused because I've never seen one before. And it was just chilling on the fire break. And then it saw me and then ran away quicker than I could even touch my phone and get it out to take a photo. And then as I continued running, obviously I got further away from it, it started howling. It was 7 a.m, by the way, at that stage. I was about 10k into Bald Rock National Park. Yes, so that's my opinion on fire breaks. And if you're going to go and send hate reviews on alltrails.com.au or the likes, then, well, I'm sorry. But it's for the best interest of the forest that the fire trails are there. So that's my opinion on them. Send me hate comments on my Instagram at treeswithsquill. That is TREES WITHSQUILL. Trees with Squill. Okay, now I will talk about bark beetles, because forest pathology in general is the study of pests and diseases that attack, if you will, a forest. And bark beetles are just one of the little fellas that make up this entire topic. I'm going to get drunk on my own in the forest, and it's raining. Oh, this is disgusting. It's 1 p.m. It's 1 p.m. They're one of the many, many disturbances acting on a forest, naturally occurring. I just did a big research essay on it. Well, it wasn't big, but to me it was, because I wanted it to be really good. I wrote about interaction between bark beetles and coniferous forests. So there are gymnosperms which reproduce via cones rather than flowers, our angiosperms. It's a lot of sperm. So focusing on the interaction between bark beetles and just one kind of forest, or one kind of tree dominating a forest, makes it easier to rule out other physiological effects, because the most interesting thing I found that I wanted to share in a podcast format related to the resin ducts in conifers, which is a feature of their wood, which is what I'm talking about when I say I should have made the wood science video first. But anyway, here we are. You're just going to know conifers have resin ducts. And so tree health is something that's measured by the vitality of the tree, and the oleoresin potential within the resin duct is one means by which we can, I guess, quantify tree health. And interestingly, low intensity prescribed burns were found to increase the number of these resin ducts in conifer forests. Researchers obviously found that by cutting down the trees, doing post-mortem analysis, if you will. So Hood et al. 2015 did this low severity fire experiment on a coniferous forest that was predominantly consisting of Pinus ponderosa, so ponderosa pine, wow, Latin. And they found that the trees in the forest were subsequently able to better defend themselves from bark beetle infestation, because productivity in the resin ducts was triggered. And this effect was found to be long-lasting. So this oleoresin potential theory is targeted. Another study, let me scroll back, 2014 study by Fehrenberg, Kane and Mitten investigated the characteristics of resin ducts in Pinus flexilis and Pinus contorta, and found that trees that had survived bark beetle infestation had significantly high counts of these resin ducts. Again, increasing the activity within the resin ducts, so this oleoresin potential overall, as a result, increased. So basically what we see is that there's a two-way street surrounding the oleoresin potential and bark beetle infestation and fire. Kind of both increase the activity of this potential, which increases the tree's potential of surviving. In general, this probably wouldn't work with little young fellas. So they've got to be old enough to have heartwood, I suppose, which is a bit of a shame. And this is a greater comment on fire, really. I like the concept of the fire trap, which is when vegetation gets caught in the cycle of being decimated by fire and re-sprouting. They don't have enough time to become adults and increase their secondary growth and thicken their bark and have those going out protective measures added to them, if you will, because time since fire doesn't increase enough. And so fire blazes through these kind of medium-aged stands of vegetation and just decimates them again, and then they become bushy little epicomic growth fellas resprouting, suckering, whatnot. And then 10 years later, boom, fire trap, they're burnt again, and it continues. So that's why it's important to implement controlled burning. So there is a mosaic of age classes of habitat across the landscape. This protects many habitat values, ecological values, all that good stuff. Okay, back to the bark beetles. What else can I talk about? Yeah, there's a big emphasis throughout my report, I suppose, on fuel loading, which makes sense, but it's defined as the relative density of fuel in a landscape. I talked about how age kind of could infer the relative density of resin ducts and also the relative survival or survivability a tree has in the facing fire. Additionally, fuel loading at the different stages in bark beetles' attack infers the relationship that trees have with fire. Because, why did I start with this? Bark beetles infestate a tree by boring into the phloem, which is where dissolved nutrients are transported, and this infestation is unfortunately slow, or the effects of it are slowly recognized by the outside world. So a tree dies really slowly. It's pretty similar across species. Eggs are laid in the spring and hatch in the summer. Beetles feed on the sugary contents in this phloem. They have the ability to fly because they're beetles, so they go to nearby healthy trees once the tree that they're chilling on is out of resources. And so it takes a few seasons for the trees to die, and they go through a series of phases, quote unquote. I think it can take up to like 10 years for the signs of bark beetle infestation to be visible, and that's when the tree grows. So the point of explaining the biology of a bark beetle infestation is to then understand the relationship that the bark beetle infestation has with changing the fuel loading in the forest and subsequently the relationship with fire. Fuel is one side of the fire triangle. So fuel interacts with oxygen and heat. In other words, a source of ignition to cause fire. So changes in fuel equals changes in fire behavior. I drink to that. Drink my juice. It's orange juice today. So it's interesting to look at the biology of a bark beetle infestation in a forest. I don't know how I was going to say that. Because of the slow going death that it causes to the trees, the way that it interacts, and the delayed diagnosis. So obviously at the different stages of the bark beetle's infestation, there'll be a different relationship with fire. One study showed that reducing density in general via thinning the trees would reduce the probability of crown wildfires by upwards of 47%. Now, crown wildfire is one that is caused by the convection of heat up into the canopy. Canopy equals crown, if you will, which is dangerous for, bird species that like to hang out there. Or completely contrasting example is the koala population in Australia that are mostly decimated by high-intensity wildfires that affect the crown that they reside in. So back to the bark beetles. These findings relating to thinning demonstrate that wildfire is likely to rip through unthinned bark beetle affected stands. Why did I read that out? I've got a lot of citations for that sentiment. Yeah, so I guess the point of that is to show that thinning's important in forests in general, given that we can't really diagnose bark beetles till it's too late, which is a shame, because I know that there are lots of communities of people out there that find it really sad to see trees cut down, me included. Don't you worry, I suppose. I guess that's why you need literature to back up management decisions such as thinning. If you don't have a clear indicator that bark beetles exist, it's just obviously a very good preventative measure. And yeah, in addition to reducing wildfire, obviously given that bark beetles can fly, reducing the dynamics across a forest, or the connectivity of a forest, reduces the connectivity of the flight or available vegetation for the bark beetle to fly to. So that's a little bonus there. I have a paragraph about the final stage of a bark beetle infestation, which is where mortality occurs, which is very easy to diagnose because the tree's fucked. This is when high wildfire severity is usually recorded, when a tree is dead, because it's very dry. There's no water held in those dead leaves, etc. The trunk doesn't have the resin flowing to protect it anymore. It's gone full circle already, that's good. A study by Hansen et al. In 2015 found that ponderosa pine trees showed varied responses to fire models in different parts of the tree. This is a consequence of the mechanism by which long-term bark beetle dieback operates. Dieback refers to the death of a tree from the shoot inwards. I love that term. Anyway, the researchers in this study emphasised that they found reduced canopy bulk density, canopy base height, canopy cover, and litter loads. Sorry. Comedy. This is inappropriate time for comedy. We assume that the reduction in these things is due to the canopy density, the live canopy density being reduced. They obviously found an increase in total woody fuel loads because the tree's dying and falling to the floor. Why did I even write that? This pattern of fuel loading change was also found in a similar study by Jenkins et al. 2008, back in the day, on Douglas fir, lodgepole pine, and Engelmann spruce. Oh, I haven't correctly used the right lexicon. Is that the word? I've done all those species names, but the second word is lowercase. It should be Engelmann spruce, both words capital. Bonus fact. Anyway, wildfire severity was also found by Wayman and Safford to increase when tree mortality prior to fire increased in the stand up to 40%. Why does that make no sense? The intensity of beetle outbreak in these studies show that an increased fire spread and severity is to be expected post-outbreak. Oh, there we go. That makes sense. So I guess I just explained in summary that bark beetles have an interesting interaction with conifers, and the result is a slow death, and the result is changing fuel loading, and the result is increasing wildfire at the end. So I guess the question on everyone's mind, why are we not, increasing the identification of infestations earlier? Or why are we not creating tools to do so? Great question, everybody. I gotta find this guy's name. Jeff Mitten! There we go. Jeff Mitten has a great YouTube video that just search Jeff Mitten bark beetles. Some guy interviewed him. It's like 20 minutes long, but it's great. He talks about why bark beetles are so hard to account for early in the infestation period, if you will, over a decade. It's something to do with the pheromones emitted by traps that don't reach as far as one would like. Additionally, and what I'd like to end with, is a comment on climate change, which is quite obviously increasing. We can fight on my Instagram if you don't believe that, but it increases the severity of all these things: wildfire, bark beetle infestation, because heat is increasing the lifespan of bark beetles, so that gives them a greater opportunity to spread. They're alive for longer. The females can lay more. It's just the epidemic is worse. Midwinter temperatures aren't as cold as historically recorded, so the beetles' larvae aren't frozen as they perhaps used to be, pre-humans perhaps, again. The longer life cycle, which means longer flight season, more trees to attack. I already said that. Heat could perhaps increase trees' growth. Additionally, increased carbon dioxide atmospheric concentration could perhaps increase trees' growth. That both these things are vital to trees. But with lack of water due to drought, so with insufficient water but increased CO2 and heat, the environment is just overall drier, which increases the stress of that the tree is under. This goes for conifers and others and bros. So as a result, bark beetles, who are directly benefited by this climate change modelling, but bark beetles not as many bark beetles are required to kill one single tree. The bark beetle population goes up, trees stress, easy. Easy roadkill. Something like that. So that's all I would like to say, because I'm feeling very self-conscious now. I thought I would be able to talk about this for longer, so that's a bit of a shame. I can send my bark beetle wildfire report to anyone interested. Just hit me up on my Instagram. That's @treeswithsquill. You know what? I'm going to read out my conclusion from my report. And I'm allowed to, because these are my words. Bark beetles and wildfires are both disturbances in forests that are increasing in severity and occurrence due to the detrimental effect of climate change. The stress a tree is under seems to be key in this relationship, as fire and bark beetles both target vital physiological features, such as resin ducts, our friends. A tree under great stress, namely drought stress, is likely to respond well to either disturbance. The nature of bark beetle infestation grades the fuel loading change in coniferous forests, and fire severity tends to worsen with time since outbreak. Because of mortality of the trees. Fire can result in a tree being under greater stress, and thus infestation rates are expected to rise. However, fire has also shown to be useful when implemented at a low intensity prior to bark beetle outbreak in increasing resistance and manipulating fuel loads. Understanding these key features of the relationship between fire and bark beetle outbreak and severity aids researchers in modelling for the future where climate change is undoubtedly controlling and increasing intensity and spread for both. What a horrifically beautiful conclusion. Stay interested in forest. We can learn a lot from them. Alright.
Me so feel great after that episode. Would you believe you've just been listening to Trees with Squill, hosted by Squillum. Music track Insane by Alfonso on Bandcamp, produced and recorded by Squillum. Follow @Trees with Squill on Instagram for more. See you next time. Okay.